Okay, we just went through a fair amount of detail talking about how to evaluate riskiness of an investment, looking at historical returns on that investment over time. And not only returns, but also variances or standard deviations as a measure of the riskiness, of the uncertainty of the investment. But looking backwards, it's useful. We need to, but it only gives us part of the picture. We also have to be able to project forward because, standard deviation gives us a measure of risk when we know what all the numbers were, right? But we don't know what's going to happen in the future. And so we can't just, extrapolate from the past as to what's going to happen in the future. We have to look at uncertainty around economic conditions or around, political issues that might affect the returns on investments. There are many, many aspects of the world that that can change and affect the return on investments. And so what we're going to look at in this section is just how do we model that numerically? How do we model uncertainty looking forward? And this kind of modeling is actually useful not only in this kind of a scenario, but also for doing projections for if you want to start a business, or even if you're doing budgets. If you think back to managerial accounting and I had you do budgets, well, remember the starting point for a budget was looking at your sales level. You don't know. You don't know what the sales level is going to be next year. And so, in my world, when we make those kinds of projections, we do a few different scenarios. Something maybe as simple as a best case, a worst case, and an expected case or a scenario. And so that's kind of what we're doing here. What we have to do is we need to look at the probabilities of different sort of states of the world and then use those probabilities to help us determine an expected return and an expected standard deviation for our investment. This is something that we call scenario analysis. If you take an upper level finance class with me, I'll show you how to do that. In a few different applications, and actually, Excel has some really cool scenario analysis tools that will just automate the whole process for you. But we're not gonna go into these right now because this is really a pretty simple scenario type situation. So imagine that you are looking at investment, and actually I'm going to just skip through this first section because it's excessively simple, and we're just going to go down to the bottom, or not the bottom, but we're going to look at an actual investment situation, which different returns on the investment depending on the state of the economy. And so a couple of things to note whenever you're working with probabilities is all probabilities always have to add up to 1. You can't have 125% probability of something totally happening, right? It's got to be, 25% worst case, 50% expected case, and 25% best case, or something like that. And of course, you would set that up if you if you were with me in a finance class. You'd set that up so that it would make it so that you couldn't make that mistake. It's easy enough to do, to have your probabilities add up to more than 1. So you just set up your spreadsheet so that they can't. The other thing is there's no such thing as a negative probability. All probabilities have to be positive. Okay, so with that in mind, then, if you think back to quantitative decision-making class, we had you do something called a weighted average. And that's basically what we're doing here. We're calculating a weighted average return where the weights are the probabilities of the different states of the world. Okay, so here we have an example. We've been looking in the bond market, And what he found was that when the economy is booming, the long-term bond return is 2. And when the economy is in a steady period, the return is 5. And when the economy is in a recession, the return on long-term government bonds is 10%. So we have a little table where those are, let's see, where those are given here, right? So I've got a return of 2% in a boom state of the economy. I've got a return of 5% in a steady state, and I've got a return of 10% here in the recession, right? And so now what we need to do is make an estimate as to what's the probability of each of those states of nature coming to pass, right? And so your example gives that the likelihood of a boom economy is 25%, and the likelihood of a steady state economy is 55%, and the likelihood of a recession is 20%. And so the question is, what is your expected return? So you've got a 25% chance of returning 2%, and you've got a 55% chance of returning 5%, and you've got a 20% chance of returning 10%, and your expected return is actually the weighted average, right? That's what you do. Now you could take and the way that this table has shown you in the book over here, you could calculate the probability times the return and then add them up, or you could do a nifty little Excel trick called sum product. And so let me find where I did it. Okay, so what you do is you invoke the sum product function, and you just lay out the 2 columns or the 2 arrays that you want to calculate for, and that'll give you this 5.25%, right? So this is the sum product of the probabilities and the returns, right? So that's just a simple, Excel function that'll get you here to the same number that they calculate out. Okay, so that's step 1. Right, so this is our weighted average, or our expected return. It's kind of like our average return from the past, right? Because what we're doing here is we're going through the same process of calculating an expected return and an expected standard deviation, but because we don't know what the future holds, we have to assign some different scenarios that might come to pass, right? So, and remember, what we're trying to get at is the expected return and the risk associated with that expected return, and risk is standard deviation. Now, calculating a standard deviation, unfortunately, we can't just take and get the standard deviation of these 3 numbers. If we did that, it would not give us a correct answer, because we have to weight the average, right? So you have to go through these steps to calculate the variance and then the weighted standard deviation. And so the way that you do that is you make a couple of more columns here. This is our step 2. You make a couple more columns. In the first column, you take the square of the the square of the difference between the return in that state and the expected return. Right? So you just take that difference and bring it up to the power of 2, right? And the way that you bring up a number up to a power in Excel is you do the caret sign, and that will square it for you. So it's the difference between our return and the expected return squared. That gives us our difference squared. And then you could do a whole column, which is the probability times the difference squared. And if you add those up, well, here, I'll show you. And if you add those up, it will give you this this result, which is 0.007, as they show in the book. You can also do it via the sum product function, but I have to I have to admit that it took me a couple of tries to keep the columns straight in my mind, so you guys might find it easier just to do this out column by column by column. So you do that, and that gives you that 0079. That's a sum product. Just like before, you take the probabilities and the variances, right? And so to get to the standard deviation here, all you have to do is just take the square root, which the way that you do that in Excel is you give it the caret sign again and say to the 0.5 power, and that'll give you the square root of this 0.0007, right, which is 2.68%. So that's how you create an expected return, an expected standard deviation in a world of uncertainty. Okay, so that's the next little piece of the puzzle. All right, so I'm going to stop it here, and then we'll move on to the next content.